Hi everyone, a very good morning to all. Now we are going to discuss about the nuclear reaction. So what is nuclear reaction? So when nucleus or better to say nuclei uh, divides into two different nuclei or two nuclei combined into bigger one, that is called nuclear reaction. See, generally, a nuclear reaction takes place such a way that in a simple manner, either one big nuclei with a greater mass number divides into two smaller one, or two smaller may combine to form bigger one, or another one is the radioactive decay where alpha, beta, gamma decay will happen. So from an atom, alpha may emit or beta may emit or gamma may emit. So what are those things is, consider any atom ZXA. When ZXA, one atom emits helium 2 helium 4 alpha, helium plus plus, then its atomic number decreases by 2 and mass number decreases by 4, and that is called alpha decay. Similarly, when you consider the same atom, it can emit two other things. One is beta minus, that is electron. One is beta plus, that is positron. Then what happens is, in case of beta minus, Z increases by 1, but YA remains same. And in case of beta plus, Z decreases by 1. But in beta decay, mass number remains same. Only atomic number changes. It may increase by 1 or it may decrease by 1. And when you consider gamma decay, there is no change in atomic number or mass number. Only some photon energy will be emitted. So based on this alpha beta decay also they can ask the question. Now another question is, like as I said, fission. Fission means breaking of one nuclide or nucleus into two stable nuclei. And in every fission, energy releases approximately, it is 200 mega electron volt. Just like uranium 235 when it bombarded with fast moving neutrons. Like the same phenomena happens in nuclear reactor. First it will become uranium 236. Then it will divide into barium and krypton. Plus 3 neutrons also will come. And here some energy releases, and that is approximately 200 mega electron volt. So one unstable nuclide divided into two stable nuclides, and that reaction we call it as fission reaction. The total binding energy of the product minus total binding energy of the reactants, we call it as fission energy, or Q value, Q energy released in the nuclear reaction. Similar way, the opposite of this one, like when two smaller nuclei combine to form big nuclei is called fusion. Why? Because see, atomic mass number less than 30 and mass number greater than 170 all are like unstable. So they may try to divide and become stable. They may combine, they try to combine and become stable. Like for example, 1H2 plus 1H2 equal to 2 helium 4, just one example. And some energy will emit approximately 25 mega electron volt in every fusion reaction. And Fission means we use in nuclear reactor and atom bomb. And fusion means hydrogen bomb. And also they explain like the reaction at sun. The enormous energy coming from sun is due to fusion, they said. Means fusion is taking place continuously because sun material or the substances it is made up of is maximum of smaller nuclei. So the smaller nuclei will combine to form one big nuclide. Means they undergo fusion process and they release energy continuously. So they said that might be the reason for the enormous energy coming from the sun. So like that, they can ask question based on these three things. So let's see. The first question is, in a nuclear decay given below, see ZXA became Z plus 1 Y into A. That means here Z increases by 1. That means beta minus emission happened. Then it became Z minus 1 B and A minus 4. Z decreased by 2, A decreased by 4 means alpha decay happened. Then from here, it became like Z minus 1, B, A minus 4. That means it remains same, both Z and A. So that means gamma decay. So beta, alpha and gamma decay. So that is what the order. You have to understand. Like this kind of question they can ask based on the reaction, nuclear reaction. Here, another question. They have given some nuclear reaction. They are asking the total energy liberated. So the total energy liberated means Q value, that is the total binding energy of the product. That means 117 into binding energy per nucleon of X plus 117 into binding energy per nucleon of Y minus 236 into binding energy per nucleon of uranium. And EBN for X they have given, that is 8.5 mega electron volt, and EBN for Y they have given as, that is also 8.5, and EBN for uranium they have given as 7.6 mega electron volt. Then just substitute and try to calculate, then you will get the answer. Now, atomic power station at Tarapur has a generating capacity. So how much energy? Mega, 200 megawatt. So 200 mega means 10 power 6. Watt means joule per second. Per second, this much of energy is generating. That means energy generating per second is 2 into 10 power 8 joules in 1 second. Now they are asking for 1 day. For 1 day means 24 hours into 60 minutes into 60 seconds. Then you just have to multiply this value time with that one. Then you will get the total energy generated in 1 day. Now in the thermonuclear reaction, the energy released per nucleon of the reactants, the total energy released is 21.6 mega electron volt. Now total nucleons of reactants, how many? Here, who is the reactant? 1H2. So how many nucleons are there in 1H2? 2. So such that 3 are there. So 3 into 2, 6 nucleons are there. So for 6 nucleons, this much of energy released. Then for 1 nucleon, how much energy will be released? So that energy will become 21.6 by 6. So 6 3s are 18. So 0.6, 3.6 mega electron volt. Like that, different type of question they can ask. Now one last and final question. In the fusion reaction, 1H2 plus 1H2 equal to, see the reaction is 1H2 plus 1H2 equal to 1 helium 3 plus 0 N1. the masses of the deuterium, helium and neutron expressed in AMU. So they have given all the masses. If 1 kg of deuterium undergoes complete fusion, see here what you have to first find out is delta M. Delta M means the masses of deuterium, helium and neutron all have given. So now you just take the mass defect. So mass defect is how much? 3.017 plus 1.009 helium plus neutron minus 2 deuterium is there, 2 into 2.015. So this difference we will get it as delta M. Then correspond the delta E. Delta E means delta M C square, or you can take it like, simply what you can take is, when you get the answer in terms of AMU, you just multiply with whatever AMU you will get, some AMU you will get. So into 935 mega electron volt. So directly we will get the answer, because for 1 AMU the binding energy is 935 approximately. Then this much of energy will be released when 2 atoms combine. But here 1 kg deuterium means, so now you have to find, what you have to find is number of atoms in 1 kg. 1 kg means 1000 grams. 1000 gram means how many moles? Number of moles means mass by molecular mass. What is the molecular mass of deuterium 2? So 500. Then total number of molecules are 500 into 1 mole means 6 into 10 power 23. These many means you have to multiply with Avogadro number. Then you will get total number of molecules, total number of atoms. Now 2 atoms will give this much of energy. Now these many atoms means the total energy released will become half. Why I am taking half? Because here 2 will give this much of energy into whatever AMU, this delta M, how much will come in terms of AMU times 935. Then you will get the answer in terms of mega electron volt. So the reaction is given, first to find delta M, then find the binding energy. That is for one reaction, means 2 atoms if they combine. But they are asking for 1 kg, then you have to find the total number of atoms, so that you can divide with 2, because 2 will give this much of energy. So that you can multiply with the binding energy of one reaction. Then you will get the total energy can be released when 1 kg deuterium undergone fusion reaction. So this is how they will ask the question based on, they can ask the similar kind of question based on fission also. Fission, fusion, alpha decay, beta decay. So just try to practice. Similar questions I have given as an assignment also. So just try to solve these questions. And in NCERT also they have given questions. So try to solve those questions also. So thank you all. We'll continue in the coming session with the another question.